Welcome, everyone, to the panel on quantum technology commercialization and adoption. It's exciting to be here today and focus on a topic that continues to increase in awareness across Canada and the world. Before we begin, I would like to acknowledge that most of us participating here today are on traditional unceded territories of many First Nations, Inuit, and Métis people. Their ancestral footsteps and rights extend beyond the boundaries that exist today. We respectfully honor these people's rights, history, and relationships with the land. Today, we are here to discuss the challenges and opportunities surrounding the commercialization and adoption of emerging quantum technologies. Quantum technologies promises to be one of the biggest breakthrough technologies of the future. A recent study commissioned by the National Research Council estimates that the total economic impact of quantum technologies in Canada by 2025, including direct and indirect induced effects, may top 533 million, with 1,100 jobs and 188 million in return. By 2045, quantum could grow to a 42.3 billion industry with over 200,000 jobs. Furthermore, the downstream impact of adopting and applying these technologies could unlock hundreds of potential cost-saving applications in a multitude of industries, such as drug discovery, logistic optimization, financial market simulations, and cybersecurity for corporation and the government. At the National Research Council, we have established large-scale multi-partner challenge programs that focus on developing quantum sensors to perform beyond the limits of classical physics to aid in defense, energy efficiency, and biomedical imaging. Applied quantum computing to explore applications in finance, cybersecurity, materials and drug design, and molecular modeling. And lastly, we have established a high throughput and secure network program focused on enabling network operators and service providers to offer quantum-based, secure, and affordable high-speed internet across Canada. The NRC's Industrial Research Assistance Program also supports firms working in the area of cybersecurity that are using quantum technologies. However, we continue to struggle on how best to commercialize and help companies adopt quantum technologies. Quantum's disruptive impact is starting to gain notice in large global companies, but general business uptake on the scope of the proposed quantum innovations remain relatively small. Many Canadian companies are still not aware of how quantum can protect their business and support their long-term transformation. And so with this, we have 5 incredible panelists with us to discuss this complex issue. Before we kick up our discussion, let me just tell you a little bit about each of them. Kimberly Hall is a professor of physics and atmospheric science at Dalhousie University. Kimberly is director of the Ultrafast Quantum Control Group. Her research is focused on the study and control of materials of interest for solid-state quantum information in electronic and photonic devices. Mark Ritter is a distinguished research staff member and chair of the Physical Science Council at the IBM T.J. Watson Research Center. He manages groups focusing on theoretical and experimental aspects of new computing paradigms such as quantum and neuromorphic computing. Eric Santor is the advisor to the governor of the Bank of Canada on digitalization. In his role, he leads the bank's digitalization work, including research into the impact of digitalization on the economy and financial system. Eric also leads the initiative to incorporate technologies such as AI and machine learning into the bank's operation. Rachel Taylor is Chief Operating Officer and co-founder of SB Quantum, a quantum sensing startup building on novel magnetic intelligence platform, which aims to reveal the invisible for clients. At SB Quantum, Rachel champions user-centered methodologies, drive cultural transition as the team adjusts from lab to startup, and is responsible for securing multiple pilot opportunities. Nick Worstyuk is the Chief Executive Officer of Quantum Valley Idea Lab, an organization that aims to bridge the gap between the academic lab and industry to accelerate the R&D of the most promising quantum technologies. Nick's broad expertise includes new product development, corporate strategy, and identifying growth markets to drive research towards commercial success. We'll start our panel discussion with opening remarks from each panelist, followed by interactive Q&A discussions. But we will be sure to leave some time at the end for the audience to pose any questions. So I invite the audience to prepare any question that they may have. And you can go to the discussion forum to pose to put your questions there, or the live Q&A. Now I will ask each panelist to provide an opening remark in the following order. Mark, Rachel, Nick, Kimberly, and Eric, and I'll invite each of them to talk about their involvement with quantum technologies and how they believe quantum technologies could benefit the Canadian economy or society. So Mark, you're in the United States, but how can it benefit us in Canada as much as possible?
Well, thanks, Genevieve, and good afternoon, everyone. I do want to thank the organizers of this conference for inviting me to the panel, and I look forward to some great discussions. I led the entire quantum computing team at IBM Research and had the idea and led the group to put a 5-qubit quantum computer on the IBM cloud in May of 2016. And frankly, a lot of the researchers thought that would be nothing. But as you have seen, many things have happened, and IBM has continued quantum computing with a published roadmap to a machine having more than 1,000 qubits by 2023. And IBM and others have chosen to invest in quantum computing because of the promise. Complexity theoretic proofs in recent years have mathematically shown some problems for which quantum computing excels over conventional computing when the scale, quality, and speed of qubit processors is adequate. These problems have great commercial value, as Genevieve indicated. However, much more research and technology must be done to realize the promise of these new technologies. And I've also been encouraging the US government to invest in quantum technology research. And I helped write the white paper that became the National Quantum Initiative Bill, which was signed into law at the end of 2018 and later funded by Congress. But I believe the quantum research is so critical and so difficult that we need to collaborate across countries with allies, the US collaborating with Canada, with UK, with Australia, with EU and other countries in order to develop these technologies for the benefit of all. And so that's why I think we must work together to make sure we have realized these technologies for the common benefit. And so that's my introduction. Thank you.
All right, thank you. Next one is Rachel, from the perspective of a SME in the environment of quantum.
Yes, and thank you. And thank you for everybody who's attending this session. It's very exciting to be part of. So my company, SB Quantum, is building a quantum magnetometer based on nitrogen vacancy diamonds. And that, for me, was a hugely complex quantum phenomenon that I did not necessarily understand going into it. But what I did learn to understand was the application and the importance for Canadians. And so there are really interesting possibilities to apply this quantum technology into defense and security-based applications that will help our armed forces do better across the world. There's an opportunity to apply it into mining, to make Canada one of the leading mining mining industries as we all move towards net zero and need to find a way to have carbon neutral solution while mining and shifting towards electric vehicles. So these are really exciting places where Canada can take a world leading role. And that's even more exciting if we can power that with Canadian innovation and Canadian technologies. On top of that, what our company has seen is that it's a fantastic way to keep high profile talent within Canada and even to bring in individuals. So we've brought people in from other world-class institutions to come and work at our company because they have the specific knowledge sets, the specific PhDs that we need in order to work on a complex and highly specific problem that we'll then take and apply out into the world so that we can really create that common good that Mark was referring to.
Excellent. Now, Nick, from your perspective as Chief Executive Officer of Quantum Valley Idea Lab.
Yes, thanks, Genevieve, and thanks for the opportunity to contribute to the panel. Excuse me, I have the opportunity to lead an interesting organization. We're a not-for-profit advanced technology research lab. Our mandate is really to look for those promising quantum research activities, provide an environment, people, lab, infrastructure, and investment dollars to fund that applied research and development, to take the idea towards commercialization readiness. The ideas and the IP then become launch content for a startup business focused on a specific product and markets. Our horizon's typically a 3 to 5 year project, so that ensures we focus on the most sort of near-term quantum opportunities or commercialization opportunities. So that's led us to concentrate on quantum sensing, and we have several projects underway on RF sensing using Rydberg atoms. In terms of the Canadian economy, right, I think there's an opportunity really to build on the strength of our academic research institutions in quantum and take those ideas forward to commercialization. So if you look at our current research programs on quantum-based RF sensing, there's a couple of things, right? One, there's a core benefit, right? Successful commercialization of these ideas via made in Canada companies will drive value add to the Canadian economy. A successful quantum-based product company has the opportunity to become a world leader and establish a unique set of capabilities that are hard for others to duplicate. On a broader sense, right, the area we're in of RF sensing, we all know about the impacts of RF these days, wireless, 5G, 6G, IoT, all that sort of increasing and larger market opportunity, right? So the opportunity to introduce new quantum capabilities to those markets, new types of antennas and receivers, has the potential to establish a Canadian footprint in a much larger market. So really excited about the opportunities to help those ideas become commercial ready and move into successful Canadian product-based companies.
Can maybe help us to share communications across the country, which is large, wide, and has all sorts of little nooks and cranny where we don't have good communications. Kimberly, as a professor, how do you see this? You train young students who want to become either as researchers in their own terms or to do this within a company. So how do you see this for Canada?
Exactly. I very much believe that part of my role as an academic is to introduce trainees to create companies. And I have one student that's already done this. So this is definitely something that I believe in. So just to introduce myself, I've been a faculty member at Dal for 17 years. And my research all this time has largely focused on various topics in quantum technology. So spintronics, and also I spent a considerable amount of time looking at optically controlled qubits in semiconductor materials. Some of the materials we study are also of interest to other areas of photonics like solar cells, but our primary focus is quantum tech. I'm an ultra-fast spectroscopist, so I just thought I'd mention what ultra-fast means. So we use very short pulses to control and study phenomena involving electrons in semiconductors. And so by ultra-fast, what I mean is that we use very short coherent pulses of light that are on the order of 100 femtoseconds. So if you were to compare 100 femtoseconds, the duration of these flashes, to 1 second, on a distance scale, that'd be like comparing a centimeter to the distance between the Earth and the Sun. So these are very, very fine temporal probe. And so one of the things we've been doing is to develop what are called optimal quantum control protocols to shape these pulses to actually manipulate their temporal profile in order to tailor laser-induced control of individual qubits in semiconductors, in particular, systems that show the potential for scalability. So obviously I'm an academic. This is the perspective I bring to the panel. But I have two indirect connections to commercialization, which led in part to my interest in participating. The one is that I did benefit from some very early IRB offset funding with a very large US company. It was back in 2009. And this gave me a nice window into how interest in quantum tech can be initiated from the industry side. And as I mentioned, one of my students did start a company, which is now has 13 employees in Nova Scotia.
That's a good story. Eric, building on this, how did you get interested at the Bank of Canada in quantum? And you're, one of the first user of quantum technology. This is exciting. So how do we convince others to do this?
Yeah, so there's sort of two ways I walked into this. The first one is in my role at the bank, we have to understand what the broader impacts of digitalization are on the Canadian economy. So we know that the commercial viability of AI and ML, big data, robotic process automation, cloud, blockchain. This has all had profound consequences on the economy. It's changing how the structure of the economy, how it works, competition, a whole bunch of other issues. And so we're always looking for what the next big technology is that could have an impact on this. To get a summary of where we are now, our Deputy Governor Tim Lane gave a speech back in earlier in the summer, talking about the impacts of digitalization, how it's mattered. But for quantum, this is something that's coming down the road, and so we need to understand how this technology could have a similar impact to some of these other technologies that have come along. In terms of its actual application inside the bank, of course, got interested a few years ago, knowing that our adoption of machine learning, it took time to build capacity and the human capital to do it, and so I knew that with the eventuality of quantum computing coming down the road as a commercially viable technology, we need to make the investment now. And so we started at the bank what we call the Quantum Lab for Advanced Analytics, which we have people working in quantum computing, often partnering with external firms, and also doing our own research to figure out how we can take quantum computing to help us answer economic questions or questions of interest to the bank. And so this is very preliminary research on how we proof of concepts of how we can do that, and I can all expand upon that later. But really the interest is, how can we be ready for when this thing gets, real and live in our lives and widespread, that we can take advantage of the technology to do, as some people would say, do our work, better, faster, and cheaper.
Yeah, so we'll talk about this later, of course, and we need more potential users like the Bank of Canada to step up and come and meet the research community and those young fledglings of startups to make sure that we have this balance between the research that's being done and the commercialization aspect. Kimberly, I'm back to you. You're looking at the future. So if I ask you, what are the gaps that should be addressed today and over the next 10 to 15 years to enable Canada to continue to grow as a leader in quantum science and technology development? What do you see? What do you foresee?
So I kind of want to highlight three different gaps. And the first is the need that we have as a country to support the fundamental research enterprise in Canada, because I think fundamental scientific research with all areas of technology is really the heart of long-term innovation. So we all know the impact that fundamental scientific discoveries have had on all of our lives. The internet was invented by scientists, particle physicists, because they needed to exchange data more efficiently. Research was already underway on the COVID, the type of vaccine we are using for our COVID vaccine now, before the pandemic happened, which we're all benefiting from. And you can point to so many other examples, whether computers, solid-state lighting, telecommunications, solar panels. All of these innovations have as their origin curiosity-driven fundamental research. And quantum is no different. So obviously we need basic research in order to support long-term innovation. But I wanted to bring this up because this area is actually a little bit different from all of the other areas, because the quantum science and quantum technology are closely linked. They remain closely linked. They're inextricable. And so to explain what I mean by this, for example, our group has been working to understand the properties of this new class of material for solar cells called hybrid perovskites that it turns out are useful to make cheap, efficient solar cells that can be solution processable. And in that case, it was easy to recognize the value of the material for this application because the application was already well defined. So passing the innovation to industry was a straightforward process. But in quantum tech, we're both figuring out how to control quantum properties and how they might be useful at the same time. So science and innovation are inextricably linked in this field. This reflects, in my opinion, both the stage of the field and how fundamentally different the innovations that are expected to come out of the field are from the technologies that we have today. So in Canada, broad-based fundamental research funding has been decreasing continuously since I entered grad school in 1995. The average discovery grant has been largely unchanged for 25 years. Obviously, we've had inflation over that time. Much more is needed to support the base of our research enterprise. But the great thing is that Canadian researchers have shown over all these years that we can do a lot with a little, right? Mm-hmm. So especially in the area of quantum tech, where there's also been significant private investment. I mean, Canadians are leading the world. But the problem is that this approach is not going to work anymore now that other countries like the UK, the EU, the US, and China are all massively investing. They've recognized the potential of quantum. And so we need to step up. So the funding announced in the 2021 budget is a great step, but just like these other programs elsewhere, it's really important that a substantial portion of this funding be used to support broad-based fundamental research in order to best exploit the potential of the Canadian research ecosystem for long-term innovation. So put more simply, we must not pick our horses too soon. So that's the first challenge and the most important one I wanted to highlight. The second one is that we do need, if we're going to bridge the gap between basic science and innovation, to increase the level of connections and communication between all the stakeholders in the space. So academic researchers, companies, governments, and end users need to talk to each other more effectively. And for this gap, I actually have a suggestion. So along with a number of other Canadian researchers, I had the opportunity a few years ago to attend this quantum technology showcase that the UK had as part of their funding program. It was essentially a trade show so they had all these booths that had operating quantum experiments, and the people manning the booth were the actual researchers, and they could explain what was happening, and they were all the companies in that sector. And it was fantastic. It was essentially a one-stop shop for all of the UK stakeholders to be in one room and exchange ideas and to connect in a way that right now we don't have this opportunity in Canada. So as a researcher, I know there are startups out there that I could connect with and work with, but there is no easy way for me to find the companies that exist and, more importantly, to find out what they're working on. So
well, hopefully with Quantum Days, we can do something like that, which is a dream of mine because I was there with you.
Yes. Yeah. So I hope you also enjoyed it.
Yes, I did. Absolutely. And you had a third point.
The third point, which I can make very quickly because everybody knows, is that we do not have enough trainees. So we don't have enough trainees because most of the people that end up becoming quantum engineers are physicists, and there's not that many PhD physicists, and the quantum trained physicists, small fraction. Obviously, we cannot grow this sector of our economy if we don't have the people to fill the jobs. And anybody that's tried to hire a postdoc in the last few years knows that we're not producing enough of these people, and there is massive international competition for hiring them. So,
absolutely, competition is fierce. So, three things: more funding for basic science, increased dialogue between in the ecosystem, industry, government, and academia, and more trainees. Mark, Nick, Eric, anything else? Rachel, anything else that you see that we should do now for the next 10, 15 years? No?
I do agree with training more people and recruiting more people and making that training inclusive, right? So that people who hadn't traditionally been incorporated into STEM fields before are enabled with the right educational opportunities. And that has to start early. They're enabled to participate in these new technologies.
Yeah, and in quantum physics, let's just put it this way, there are not many women in Canada. There are a few, but not that many. So talking about inclusivity and diversity, definitely we should explore that. Mark, my next question is for you. How do we ensure that we can increase the risk tolerance of companies to adopt quantum technologies? And how do you demonstrate the applied benefits from quantum technology? So when you're talking about IBMQ and you're trying to make sure that businesses make use of it, how do you do this?
Well, Nick and Eric touched somewhat on the benefits part, and let me just add to that and start first talking about the benefits. I believe that if benefits are actually demonstrated, companies will then begin conducting their own risk-reward planning to adopt the technologies. As they see a benefit in one particular area, they'll start thinking about how it could apply to their own business and what the reward would be. Think of computers back like to the IBM 701, the early computer in the 40s or early 50s. Thomas J. Watson said, oh, there will only be one or two sold in the world. Of course, he was terribly wrong because he didn't understand that people look at something and they say, I could use that too. And not only that, I'll remind you that back then, people didn't think at all about putting a 701 in a car because it was impossible then. But as technology improved and cars advanced in technology and the technology miniaturized, now there maybe are 30 processors in your car doing different things and purpose designed, fit for the car environment, a much higher static electricity tolerance, et cetera, and heat tolerance, et cetera. And I believe quantum technologies will be just like that. Will show benefit in certain areas at first, and people will say, yeah, but I could also use that over here in my business. And that's where the education becomes critical, because people right now, some people, the early adopters, are realizing, like Eric described, we need to have a group in our company understanding these technologies and how we might apply them. Those are the bleeding edge, technology companies that understand there may be something here computationally or for sensing or communication that would give my company a special benefit. That's why I started with the benefits first. You need to educate the people in those companies who are the thought leaders who see the benefit of technology for their business. And so that's how I believe the quantum technologies will really take off. Early adopters are the technically sophisticated clients with really hard computational problems or sensing problems or communication security needs, and they're willing to go out ahead of the pack. But once they prove the technology, there will be many who follow them and develop the technology more to their needs. And I think that's one of the things that we need to do is we need to have a clear theoretical underpinning for some of these technologies like quantum computing, for example, or sensing, to show how much better the quantum technology could be over conventional technologies. Whether it's that complexity theory for computing, or it's some sort of demonstration or proof that the sensing can actually achieve better sensing than any traditional technology, given noise and other sources of interference. And the second thing, there must be clear benchmarks of efficiency, speed, or quality of sensing, whatever it is, that really show that you can do better than the existing technologies. People want that. Clients want to see that. They don't want vague discussion that sometime this will be better. They want clear benchmarks. And I think the last thing is people have to demonstrate that advantage with clear benchmarks. And once it's demonstrated, then the business will really pick up. And they have to be demonstrated on practical, hard problems that business really wants to help them in their business. And that leads to the second part of the question, which is increasing the risk tolerance of adoption. And again, I think that there are certain companies that are balanced toward higher risk, and they realize if they don't keep on the forefront of technology, they'll miss out. And that's kind of the FOMO effect, fear of missing out, right? And they will invest earlier than others. If the economic climate is right, I think people take more risk. So that's also part of the issue, is what the economic climate is. Allowing companies to trial technologies in test beds or government-funded access can also help develop protagonists within companies who are the expert first adopters and advocate that technology within their company. But again, it must show some benefit or promise of benefit. And I include, of course, startups in this, and there, Nick and his funding of different startups is very important to get technologies applied in niche areas or new areas that perhaps people like IBM aren't thinking about. And if they had loans backed by government, for example, to buy down risk, that would actually help more people like Ginnie Mae or Freddie Mac is buying down the risk of making mortgage loans in the US. So having some similar thing to buy down the risk of loans to startups might also help them. And of course, there are VCs like Nick's firm. And however, in the end, all the investment in new quantum technologies will really take off when people really show advantage in some area. That's a practical problem, not theoretical, but a very practical problem that they can really solve better. And that in the end will drive everything. So those are a few thoughts.
Well, I'm tempted to go to Nick and to Rachel with this question. How do you increase the risk tolerance of potential buyers of your technologies?
Can I tangent a little bit into a thought around the part of the getting around this risk tolerance and being able to provide these data points that Mark is quite rightly saying are required in order to feel more comfortable with the risk. But I really liked his point around education. And I think this is actually an education piece, both directions, because one of the fundamental features of quantum technologies is that they are a technology looking for a problem. So in the startup literature, everyone always talks about how we, need to have a problem first, and then you develop your technology to suit the problem. But what we have here is a whole lot of hard and tricky problems and a whole lot of technologies that are looking for a problem to solve, and two communities that need to be able to talk to each other very early on in order to provide that matching and provide those iterative developments of the technology to make sure that we are therefore solving the right problem. But some of that is education, both directions. And as he said, the early adopters and getting involved at those early stages so that the entrepreneurs know what the key issues are and can start pivoting their technology early to be relevant for those big problems, rather than waiting until they're too far down the road and they're too entrenched into features that might actually not be that interesting for the end eventual customers.
So pivot early in order, if you understand the needs of your customers, of your eventual customers. That's a good point. Nick?
Yeah, I think there's I always think of the problem as bottom, market problem down and technology capability up, right? And we're sort of talking about that challenge here as we discuss this, right? We're not really sure what quantum can enable yet in terms of its technical capabilities, right? There's lots of research ongoing, but we do kind of have a sense of the problems, right? Like if you go to a bank and having worked with a lot of capital markets firms over the years, right, that fear of missing out is very significant that Mark talked about, right? If you can price an instrument faster than your competitors and make more money off of that capability, investments will be made in technology that addresses that problem, right? So they will go looking for solutions. So I think there's kind of a challenge here, right, is having a clarity of what problems, you think you're going to solve with the technology. And then, as Rachel said, sort of iterating towards the technology up to kind of closing the loop to solve that problem and demonstrating it's got to be some factor, right? It's in simple language, cheaper, faster, better than what people are doing today. And then that's going to be the metric that sort of de-risks it, for a lot of people as they try and select the technology that makes sense, that can solve a problem for them.
Absolutely. Eric, my next question is to you then. how can the government work with academia and industry a little bit in the ways that Kimberly was talking about earlier to better support commercialization and adoption of quantum technologies? How do you see that?
Yeah, so much has been mentioned already in terms of the funding and other aspects, but I think one of the big elements that we can, where we can step in and help, in a sense, is to actually start doing this stuff ourselves. And so, at the Bank of Canada, what we've done is we've started this quantum lab for advanced analytics. We wanted to understand how quantum computing could help us better, tackle the questions that we have in front of us. And, in economics and finance, there's lots of questions about optimization, a lot of questions about networks, how to solve those very complex problems, also computationally heavy. And so what we decided to do is we're going to do proof of concepts, just take some economic questions or optimization questions that we had in front of us and try to address them using quantum computing. And so, but that said, we're not an institution full of quantum computing experts. And so, you have to have a couple people who know how to do it, but then really you have to start to leverage up the expertise that's out there. And so our strategy so far has been to try to, partner with external firms to do these proof of concepts. And a great example very recently, for those of you who happen to be at the Qubits 2021, we showcased work that we did internally in partnership with Multiverse, which showed it was a question looking at cryptocurrency payments and networks using quantum algorithms to try and solve that problem. And so that was a proof of concept that was done with an external partner. And we have several, this is what we've been doing. We're 4 underway right now. And the idea here is that, we gain expertise along the way. We demonstrate that this stuff can work. We understand, we engage with an external expert, and hopefully we learn a lot from them and they learn a lot from us. Because often what you have out there is a lot of companies that have a technology or some algorithms that they can use, but they're not actually sure what the right questions are or the questions they can apply them to. We've got lots of questions constantly coming to our minds that we want to try and solve. And so meeting that, having those two things meet can be very helpful. And so it'd be, I think, advantageous for, different institutions, organizations to start making that investment now in the proof of concepts, building some capacity, and then getting this two-way learning going, that there's lots of questions out there. Some are suitable and some are not. And part of that process, of course, there's going to be a lot of learning. By learning, I mean, there's going to be a lot of things that simply don't work, right? You're going to try and answer a question. It's not going to work. And you have to learn, understand that's going to be the way it is, and move on to the next one. And hopefully you've learned enough the first time to not repeat the error again, but you'll have to learn along the way. And so this is where I think parts of the government can be very active in taking that step, hiring some, getting some expertise in-house, interacting with academia, private sector out there to do the work that you want to do, and start building those networks. Because this is also about building an ecosystem, across the country, both in terms of academia, government, private sector, where we're all having the conversations that we need to have about how we can push this step ahead. And so, we're very active in different fora. We try to, we're starting to present at conferences, starting to meet people and have these conversations, to think about where it's going to go next. And for us, it's also about understanding where the frontier is and and what's demonstrated to work. Just as Mark was saying quite clearly, there's a set of questions that can you do better in optimization? For example, we have a proof of concept looking at Monte Carlo simulation and quantum computing. Is that an application that you can do the thing faster? Can you get quantum advantage? Trying to test that out. And the quantum advantage is not just that necessarily that goes faster, but maybe also the energy use on this is going to be lower. Because I think what we don't appreciate, we're all very interested in greening our operations. To what extent can you, if you get a lot of heavy computational use coming at you down the pipe, which we all do, can we use quantum computing actually to, is it going to be more efficient on the energy side? And some estimates say it can be much better in that dimension. So again, there's many different aspects that we have to start thinking about this to get where we want to go. So that's what we're doing. I think it's essentially you got to get your hands dirty, jump in, make an investment, and know it's going to take some time to pay, but build that human capital. So when it does come down the pipe, commercially viable, you can, you'll be ready to take full advantage of it.
So you have to have patient capital in certain ways so that you can experiment with this and find out how can this technology be useful for the bank. And I understand what you're saying about having the expertise inside. Not always easy. Kimberly just told us the trainees where we don't have enough of them to be able to support fully the ecosystem that we would like to see.
Yeah.
Rachel, on this, sorry.
Yeah, and on that, so we at the bank, what we've done, we have the quantum lab is also a community of interest, right? And so, while you don't necessarily have to have a person, specifically in quantum computing, you can have somebody who has a PhD, say, in some other, very high technical application who wants to learn about it, and so then they can make the investment. You're willing to put investment into that person. Certainly, people on the IT side are often have an interest in high power computing, and so they have also some expertise they can bring. And so bringing in and this is where it's very important to build teams around these things, that the different team members can bring different expertise to helping you answer this question. And also the other thing that we've learned over time is you have to have someone from the business in on the project from the get-go. So it can't be just a technical person trying to answer a business question. You have to have teams built that have the data person, the IT person, the quantum computing person, the person from the business who's got the question in front of them, to have that team try and answer it together.
Rachel, you were nodding, so I'd like to hear your thoughts on this.
I think it's so important to have everyone in from the get-go and to really have all of those people together. I'm very much a fan of this thought process. I also thought it was interesting what Eric mentioned in terms of patient capital. So a lot of the interesting quantum sensing and quantum hardware evolutions that are coming through in Canada at the moment are exactly that. They're hardware, and hardware takes a long time. Hardware and startups in particular takes a long time because there's a lot of evolution to happen. And so having customers eventually who understand that and who are willing to take on some of those more advanced timelines is critically important to be able to build those capabilities to answer those questions.
Any other on this? Any other point that you would like to bring to light? No? Okay. Rachel, you're next. And I'd like to ask you, what kind of enabling conditions are needed by SMEs to support market readiness for quantum technologies? Because we need to do this match like Mark was talking about earlier. So what is it? What are the enabling conditions that enable you to do this?
So I think from my perspective, there are three core enabling conditions, and they kind of relate to the lifestyle of the life stage of a quantum startup, you could say, a quantum SME. First, you need to roll out of the lab, and you need to find a way to really set up as a business and to establish yourself, start to understand what that problem set looks like. And there are a number of really fantastic initiatives at the moment. There are challenge programs that are coming through NRC. There's the IDEAS program that comes through DRDC, where there are specific challenges that are put forward to people who used to be researchers who are moving into having more of a business so that they can understand clear client needs and develop a technology towards that from a very early TRL stage until they get more up to the TRL 7, which is where you can really start to demonstrate to people and, to Mark's point earlier, start to communicate some of those benefits. We need the support through that process in order to move companies to the stage where they can really be engaging with customers and with the wider business community. So I think those programs are absolutely essential, and I'm really excited to see that there's a lot more rigor that's rolling into them. So we're getting more engagement from the end users within government at an earlier stage, rather than them just being written as a challenge statement that's kind of in a vacuum. Getting those key influencers and the people who might eventually be procurement opportunities in from the very beginning is absolutely essential to that process. The second step, therefore, and the piece where I think there's potentially the biggest missing section at the moment within commercialization for SMEs is really that piloting stage and the product market fit. So finding opportunities to support primarily financially. There's a lot of fantastic non-dilutive funding available within the Canadian ecosystem. There's all these different catches in all these different places, and a lot of them require some evidence of product market fit for you to be able to qualify for them, or some degree of certification for you to be able to show that you're about to scale your technology. But there's this critical stage between where you've started to develop up to your TRL 7, you've got a product now, you've got your MVP, you kind of know broadly where it is, but you don't have have the case studies yet. You haven't quite demonstrated exactly what that product market fit means. You don't have that core KPI that you can put in the pitch deck that's going to fundamentally sell your product from that point on. So this is where we need either early adoption from government branches, and so some of those procurement opportunities to give pilots that build case studies, and also programs that provide funding specifically for product market fit challenges that companies can apply to so that they can kind of bridge this gap and take that critical step between being something that's a solid MVP with lots of great ideas into I know specifically how I'm helping you, and I have all of this fantastic inbound interest that's going to let me take off. My third point is really around the transition of mindsets. So as you're going through this journey, you need your excellent quantum physicists with you the entire way. You need all of your very intelligent young PhDs, postdocs to become part of this journey. But there's a cultural transition that comes within SMEs. And when you're a small team, you don't have the opportunity to hire 15 business people to balance out those capabilities and skill sets. So one thing I would love to see is some of that entrepreneurial education coming into maybe academic bodies in order to help some of our researchers and some of our young scientists to understand what's required to exist within some of these work environments, and support and training programs to help them make that transition, so that once you need to hit the ground running within these small businesses, you have the top technical experts who really are the very forefront of their field, but they're not going to get tripped up by things that are basics of kind of working practices and hitting deadlines and all of these things that we might not like within a research context, but they're absolutely essential for the delivery of projects.
Yeah, it's not entrepreneurship is not something that everybody has as a talent right from the start. Kimberly, how did your student start up? How did what tools did he have? I presume it was a man. So what tools did he have to start up?
Yeah, so we had CDL, which is Creative Destruction Labs, runs a program at Dell, and he participated in a workshop that was sort of like that TV show where everybody pitches their ideas to these rich guys and they decide who they're going to. I can't remember what that's called. Yeah, it was like that, and it was a rigorous program, I remember, but it was highly beneficial for him, and he was able to get funding through that program, and then it just took off from there. But that was an essential step, I think. There's no doubt about it that the Creative Destruction Labs played an essential role in his case. I'm sure there's that. I think Creative Destruction Lab is all across Canada, isn't it? Yeah.
I met my co-founder through Creative Destruction Lab.
Yeah, pretty much. Nick, we're talking about education of entrepreneurs here and tools or infrastructure. So what type of education and what type of environment would be required for the government and large companies to adopt quantum technologies? And what about SMEs? We are a country of SMEs, so how do we do this?
So I actually have maybe a sort of a different point of view on a couple things there, right? And hopefully that'll get some discussion going. So I think I see kind of two ways this kind of happens, right? One is, I think we've talked a lot about, I'll call it the quantum-led adoption. And then I'm going to contrast that with the quantum inside adoption, right? So in the quantum-led, right, Mark actually talked about this notion a lot earlier, and Eric sort of built on it, right? You're introducing a quantum-specific solution like computing to solve a problem in a specific industry like financial services. So you have to have the application developers and the skills and build that quantum capability inside your organization, right, to do that, right? They need to know how to program for the new paradigm of a quantum computer, need to know how to develop for it and the tools and all the skills around that, right? So that's going to be a set of skills that have to be built, right? And, there's analogies on that, right? We've just gone through the wave of GPU computing, right? And if you look at all the effort that was put into CUDA and SDKs from organizations like NVIDIA, right? That's a 10 to 15 year journey. CUDA 1 came out in 2007, right? And we're 14 years into that GPU programming journey. So, there's, and how much work was put into building that community of skills and interest of people essentially porting their algorithms and their applications to take advantage of a new capability, right? So big organizations, as I sort of mentioned earlier, right? Big organizations have the heft and the interest to do that if they think it's going to lead to some radical business benefit for their organization, right? So I think the forward-thinking ones will make those investments early and look for those opportunities to have differentiation. The quantum inside, right? I'm going to contrast that a bit, right? And we talked a bit about it. Maybe it's in the world of sensing, but I kind of think there's an opportunity here to kind of, make a capability or a new product, right, that has quantum inside, right? So, in some cases, magnetometers, gyros, RF sensors, right? They're classical devices in the market today that solve problems. You can buy those. There's market segments of certain sizes and shapes that analysts track. So fundamentally, people know how to use those products today in the market and solve problems with them. The innovation of the quantum capability is to make them better along some sort of dimension, right? So in that case, right, you can essentially simplify the adoption by making a product that solves a specific problem. Now, that's a much more focused conversation, but I think has a potential, right, to smooth some of the adoption where people just get quantum inside of a new magnetometer or a new RF sensor, and it just operates better than what they had in the past. Now, that's a real simple view, but the one comment I will make on that is that does change the dynamic, because the supply chain of supporting and enabling people to maintain those capabilities changes a bit, right? I go from an all sort of classical electronics capability to now some quantum capability that may have lasers and vapor cells and all sorts of different technologies inside. It may hide it from the user, but not from the support and maintenance chain that needs to support that for those users. And I think that, that could simplify adoption if we can find those, good product market fits with a set of quantum technology that just does a job better for some end user in the market today, right? So I think that kind of is a contrast, right, of a discussion, right? Kind of the quantum led versus the quantum inside. And I think when it gets to some of the SME cases, right, a lot of SMEs probably don't have the horsepower and the investment to become quantum computing programming experts. So I think they have to find a model where some of those capabilities get brought to them inside of some other solution set or some other product that they can take advantage of and get the benefits of quantum through that means.
We can't hear you, Genevieve.
Self unmute. Sorry. I was wondering, do you have you seen some SMEs interested in creating quantum technologies that were not quantum to start with, but could see the advantage of it?
So in some of the areas that we're sort of early on in our product, some of the things that Rachel talked about, right? So we're doing that pre-startup because we're doing it in kind of this advanced technology research lab model. And so, we're having some of those conversations with ecosystem players and say the RF ecosystem. And it's an interesting range, right? Like if you go to somebody with a message that says, I can give you an RF device that has an increased level of sensitivity or increased performance, right? If they can see its potential in a classical job that they do today, then the interest goes up, right? As long as there's another dimension in there is the classical size, weight, power, cost, right? So it can't be $100,000 problem today with a $10 million price tag, right? It can't be, a refrigerator sized when it's a desktop size today, right? So all those things have to be part of that conversation. But fundamentally, we are seeing, some mid-sized companies take interest in some of these technologies to really try and understand, to see where it might fit in their business and maybe something that they could use to facilitate a growth of their business, sort of embedding a solution around a quantum-based technology as they go forward.
Rachel, do you foresee your clients as being primarily SMEs, or do you foresee also having important companies? So how do you see the ecosystem that you would be serving to?
I'm very much in alignment with Nick. I think eventually most SMEs are probably going to have to sell to big established major players in different industries, if nothing else, because they have the purse strings to really support that. And what I would say is that from his perspective of the quantum inside, you see the exact same trend maybe in the other direction from a lot of the quantum SMEs who are currently going to market. So people who start by talking a lot about their quantum technology, realize that they're going to have to find some product market fit and start selling some things more quickly, and then find a kind of semi-classical, semi-quantum solution that they start to sell to validate the industry, to build out the surrounding capabilities with a roadmap to when it's going to become quantum.
So kind of a hybrid to start with, just to demonstrate the power of quantum technologies. Mark,
The power of the systems.
The power of the systems that you're offering them. Yes, absolutely, because it's integrated into a system. Mark, how do you see this? You're nodding as well to what both Nick and Rachel have said.
Yes, I see it the same way, even for quantum computing. There's a known trade-off between classical computing you spend and the efficiency of the quantum algorithm. There's a lot of compilation to be done. There are parts of the problem that are better suited to the classical computer. And so this is where domain expertise of different companies needs to be applied to, in this case, quantum computing, but really it's any quantum technology, to understand, and this is the education part too, to bring them up to speed so they understand and buy down risk through that education. They understand what kernel of their own problem is best suited to be eventually made a quantum part of the problem. In computation, of course, it's Amdahl's law. You want to be able to handle the computationally hardest part of your problem with a quantum computer. And unless that computationally hard problem is over 90% of the time you spend, it's not going to buy you much to accelerate, say, only half of your problem. That doesn't. So you need, and people understand this. They're doing the computations. They really do. Yeah. And so they say, I will spend time compiling now with a classical computer and doing certain things if I can get a big win in this computationally hard part of the kernel. And so there will always be a trade-off between how much you do classically in the compilation, how much you do quantumly. And the quantum part at the beginning, we only have noisy intermediate scale quantum systems. So you're doing more in the classical part and trying to find computationally hard things like material science and chemistry that really are difficult to do with conventional machines. But that separation will change with time as the quantum systems gain in capability, so that more and more types of now classical problems can move to the quantum domain. The same is true with the sensors. And communication, of course, is a special area that has to do more with security, and not so much with bandwidth, but really ultimate security there. And that's another thing that we can discuss. But I think an area, both sensing and communication, where Canada has a lot of expertise. And I think those are areas that you can really make a difference in the world.
I can't remember who spoke about education, but educating your client, your customer, will be so important, because the layperson is just afraid of everything that you've just said. Well, where do I start? Which platform do I use? Which algorithm do I use? Kimberly, how can we help that to evolve towards a better, I am tempted to say better educated customers, or aware?
I think one thing we haven't really talked about yet is more general outreach, right? So we've talked about the need to have a communication between people that are inside of the quantum space, so all the stakeholders, of which many of them don't. We need to talk to each other, but the one thing we're not doing is talking to the public. And that will in large part solve the problem. If everybody knows something, then that is a good starting point in terms of a more advanced communication between us. So, and I also think that outreach is critical to get organized on. I mean, each institution has a little bit of outreach that's going on, but as a community in Canada, we need to have Canadians understand why quantum is important and what the potential of quantum is. And I feel that the government has to ultimately organize that communication, because otherwise there will never be enough of an appetite within Canada to fund this the way it has to be funded in order for us to compete with China and the US and the EU and other places.
Do you find it difficult to recruit students?
Yes, it's very difficult to recruit students. I mean, it's a madhouse of competition between the universities across Canada, like pitching top-ups at people. I can't emphasize enough how difficult recruiting is. I mean, obviously we have a good pool of international students to draw on all the time. Everybody's hiring international students. And Canada has the advantage of, being a little bit easier to hire people from certain places. But recruiting is a big problem, and the outreach would also contribute to that as well.
Yeah, because so the students that are going in STEM are not necessarily aware of what quantum computing could be, or what quantum communications or quantum sensing could be and could bring to their training.
Yeah, I mean, I just want to add that, quantum computing has been discussed for a long time, and I think some of the public might think it's old news or that it never worked, or, I mean, it is definitely the case that it would help us to recruit people if everybody understood right now how awesome the applications are that are really coming into be, because I think a lot of the general public thinks it's old news.
Yeah, and it's a disruptive technology, so it takes a while before people understand what it can actually do. Now, I'm going to invite people from the audience to prepare questions as well, and to let us know if you would like us to answer one of your questions. So there's the discussion forum, which is below on your screen, where you can paste some of your favorite questions that you would like people to answer to. But we still have a few minutes, and I have a couple of potential questions in my sleeves. So one of them is, I think you've responded to this already, but what would it take for Canada to become a world leader in commercialization and adopting quantum application? Can you think of a special approach that would do partly that outreach that you're talking about, Kimberly, that would tell your potential clients how useful it is to use quantum? And maybe we need someone like Eric to tell others how beneficial for the Bank of Canada quantum computing might be. So anybody would like to tackle this one?
I think it goes, I'm happy to take a stab. I think it goes back to what Mark said at the very beginning. The success of this to take off, for big investment to come, for people to use it, is going to depend on demonstrating value, the value proposition of this thing. And I think, and a realistic demonstration of the value proposition. There's always lots of hype around new technology, but we have to be very realistic. We have to be candid and realistic about what works and what doesn't. But when something works, we should almost be shameless in its in advertising that this worked in this dimension across these criteria, make it transparent and show how it was done. Particularly when for the public institutions in particular, where we're not worried about the technology being better, the profit motive here, where we want to demonstrate the public good aspect of this. We need to go and do that, and so we can provide that value as these values sort of build over time, to go out there and share the success and share the failure, but to be being realistic about it, but getting to that point where people see the value in it, and that's what's going to make it take off. So that was demonstrated with machine learning a decade ago, and it took a while to get there, and it's going to take a while to get there here too, but it's coming. So as it comes, we need to be out there telling the story.
Yeah, anything we can do to shorten that amount of time that we want people to adopt these technologies. Nick, is there something you wanted to add?
Yeah, I was just going to say, right, like I think the way that happens is you get a product-based business that has a product that solves a problem, right? And I think getting to that stage, because I think Rachel touched on some of it already, right? Like, because if you're a startup and you've solved a real problem and you have a way to solve that repeatedly, you'd be singing that from the rafters, right? In terms of the opportunity to promote that, get some sponsor user, big customers, right? So I think if we can sort of find a way to get people to that stage, right? So take the ideas, progress them, get them to a stage where they're sort of viable startup product-based businesses, then I think we can we can sort of proliferate the adoption of those technologies, right? Because you get to the proof, right? Because the startup's not going to survive without proof of that and demonstrating that the technology will do something useful. And I think some of what happens early in those cycles, if we could find a way to get some of the bigger Canadian, industrial partners, the bigger industries involved earlier, to provide some of that sponsorship of use cases and real user problems, right, and get them to the table to sort of be a bridge, then those proof points that the startups and those new innovations have get mapped to real sort of significant industry problems with significant industry customers. And I think that's kind of the magic elixir to sort of make this, to help scale this community and make an industry here in Canada.
Tyler's asking an interesting question. Is quantum now where nano was 20 years ago? Is there a comparison we can draw? You just drew one about machine learning and the fact that it took time to do the machine learning. Is there a comparison we can draw? And if so, what could we learn from how nanotechnologies were deployed or artificial intelligence was deployed? How do we need to prepare and educate society to accept and adopt the technologies? Yes, Mark.
Yeah, I believe that it is not comparable because nanotechnology was built on earlier technologies and people already knew what it solved. And
So
there
it
were
was incremental.
demonstrated benefits. So nanotechnology 20 years ago was just turning the crank on shrinking transistors, which already worked, frankly.
Yeah.
And then there were some new technologies that came along with nano too, like MEMS, microelectromechanical systems, and so forth. They aren't actually older than 20 years, but more adoption, like in airbags in your car and so forth, started 30, 20 years ago. So I think it's somewhat different because people are saying we can do this, but it hasn't been demonstrated yet. And so just to what Nick said and Eric said, I mean, the adoption will depend on really demonstrating that quantum shows an advantage. And then how it's deployed and how it is used, again, there will be differences, but I think the key similarity is you have to be solving a problem that's a practical problem people have. If you can't solve it better, faster, or more efficiently in the way of using less power, people will shrug. If it's very sensitive and it won't work in certain environments, it won't be used in those environments. And all those details then drive new research on those technologies to make it work in environments or in cases where it could be a benefit. And so I think the main thing is that the public needs to know why quantum is better, not how to think in a quantum way, because let's face it, people don't know how cell phones work. If you ask them how it worked, they couldn't tell you nothing about it, but they know what it does. And if we would just concentrate on that part of the education, instead of trying to teach them quantum physics, I think we'd be much better off, right?
Yeah. Just make sure that people know the use of it and the benefits of it. We're coming back to the beginning of this workshop where we said that you can reduce the risk by providing the evidence of the advantage and the benchmarking that you were talking about. We have another question from Anne Ingo, which is to you, Mark, or I think. Mark Ritter discussed the need for benchmarks of efficiency, speed, quality. What work is being done to develop these benchmarks in collaboration with everyone who would benefit from or need to use them, industry, international counterparts?
Well, let me say that this is an active area of academic research. It is a very hard problem to develop benchmarks that properly define a quantum system because quantum systems have exponentially large number of states. And so just like I held up my cell phone, you can no longer verify that every transistor is doing what you think it should do in a chip before you make it, because of, again, very difficult mathematical problems and combinatorial exponentially large number of states a machine may have. Well, quantum is even worse than these classical computers. So it presents a keen academic problem. How do you confirm that a quantum device is doing what you think it should, especially when you have many qubits or many devices interconnected and entangled in the quantum way in a network? That's an area of active academic research that needs to continue. There need to be also practical benchmarks.
Yeah.
And that would be more like machine learning does practical benchmarks, because many times machine learning, you can't really prove why it's working well. Your own expert, Jeff Hinton, University of Toronto, I've heard him speak many times, and I know Jeff. And he said, yeah, we don't really know what deep learning is doing, but we know what it does. And so you have benchmarks. It does this better than some other technology. And so that's what the real practical benchmarks are. So there will be a theoretical side, complexity theory and working out how to really understand the quantum. And then there will be a practical side. I think you need both types of benchmarks and metrics. That some are applied, some are academic, so we push further in our understanding of quantum systems.
And some will
Can
be
I
the
add
trial.
in here just
Yes.
on the idea of the practical benchmarks? I think there's also a space for the community to get creative in terms of what some of those benchmarks might look like. I think the practical benchmarks are often based on, particularly if you say take sensing, industry established versions of what is the primary condition or the primary benchmark that's going to be of importance. So say one example would be shooting for sensitivity. But as been mentioned a little bit on this panel, there are all kinds of noise constraints maybe that influence sensors that are often very influential. So potentially that's somewhere where quantum can really pay a difference. And so that's also about having enough of those conversations between both industry and academia so that you can take established practical benchmarks and say, okay, that's fine, we can hit that. But the real advantage sits over here with this benchmark that you didn't even realize was a benchmark yet, because this is where the differentiation really lies.
Oh, that's interesting. Anybody else on this question?
Part of that's also going to be establishing what are the set of questions that you simply can't answer in the classical world, but you can answer, you are able to at least take a crack at in the quantum world. And I mean, that's I think a bigger, that has all kinds of opportunity, but I think we're probably further away on that one, as opposed to just saying, well, I can solve this particular optimization problem 20% faster. And those are the easier ones. But it's the, what question can I answer that I can't now? And there are a set of questions I haven't even thought about that this thing could answer. I mean, that's the really exciting one. That's a little down the road, but that's where you, but to get there to that place, you have to do all this work first. So
there's work ahead for sure. Yeah. Seppo is asking how much time we have before the public and funders might start thinking quantum similar to fission power. Always decade or two away? So what do you think? Is the Bank of Canada going to invest in quantum technologies outside of the bank? You're already investing in some ways because you're supporting some of the SMEs that are involved in quantum. I know that there's a deep tech fund from the BDC that's looking at quantum. But how long before more traditional type of venture capital funds actually get interested in quantum? What do you think?
I think quantum is already a buzzword for a lot of funding. And I think actually in some ways, like funding is starting to happen now. There are opportunities. The most recent government initiative and policy around bringing out more quantum support within the budget was a great step in that direction as well. We can, of course, always do with more funding, but we do run this risk of just tagging quantum. So I think Kimberly mentioned earlier as well, people thinking that quantum's been around for a long time before it can really do anything that's particularly useful for people to feel like there was success. So an element of that is making sure that the funders are doing so in an informed fashion and doing so understanding the timelines that are involved and are doing so for the problems, not just for the quantum tag.
Absolutely.
I did want to say, I just want to mention that I don't think a lot of the general public are aware of applications of sensing. For example, most people are aware of quantum computing, like computing. So they say, oh, I have a computer. This computer runs faster. This is the extent of application, but sensing is close. I mean, and it's easy to explain and easy to understand. I mean, in a superficial way, at least. So this is something that I think needs to be emphasized in terms of the value added by quantum. In addition to computing, we have other things that are probably closer in time.
I think one of the challenges with that, Kimberly, is that as you know, right, the computing is this big, broad, general capability that can solve many, many things as we go forward. One of the challenges we always find is the sensing tends to get filtered down to being a specific end user product. And so I think that balance, right, the thing that catches everybody's attention is the big general, we're going to solve all these computational problems faster. Whereas I think one of the ways to address this funding question is to, produce some shorter term sensing outcomes, right, that can drive real benefit in the market now, right, and sort of show that quantum is making real steps forward in terms of a technology enabling new and innovative things.
But in order to do that, I think we need some different people getting involved in the funding. I agree completely. But if you look at the classical VC model, then that's where the shift back towards more of the quantum computing and I want my unicorn business that's going to go on to break everything. It's really difficult for a quantum sensor with a very niche and specific application that's going to be very useful for the industry to have that billion-dollar business kind of like market segment looking forwards. So I think there's a little bit too about finding alternative ways of doing some of that funding so we can support both types.
Yeah, that's a really good point, right? There's a lot of money flowing into the home runs, right, where there's lots of singles and doubles to be hit here in the short term, right, with some of these technologies, and trying to find a way to make that balance.
So you stole one of my questions, which was, hey, what type of technologies do you think will be among the first to be adopted in the near future? And what do you think?
Quantum sensing.
Sorry? Sensing. Yeah, I think that's what I'm hearing. All right. We have maybe one last question from Amy. How should research security be addressed for quantum technologies in Canada while still maximizing the ability to commercialize? Now, that's an interesting question. How should we think about this? Other countries are investing heavily in quantum. And we've invested in the last 10 years, we've invested $1 billion. Now, we're adding to this new funding from the National Quantum Strategy. So how about research security, which is also a subject in the United States as well, Mark, isn't it?
Right. And let me just say the National Quantum Initiative, I've encouraged people in the NQI and the Quantum Economic Development Consortium too, that we need to collaborate internationally. We're at a pre-competitive research stage in many of these technologies, and there needs to be collaboration. I think that when companies put their own money in or VCs put money in, then the IP and the IP creation and the IP rules protect your developments. And that's how we have worked in the Western world. And I think it's a wonderful way to do it in a very open way, because people then can help you if you agree to work together and share IP. And then you protect that IP. Otherwise, the government-funded work should be open and allow collaboration across borders. And that's the way I have encouraged people. Of course, there are actors in the world that perhaps we don't trust as much, and I think that's the question there. And for that, it's always very difficult to understand. I think the best thing that Canada and the U.S. can do is simply run fast.
Yeah, faster than the others.
Get there first, and I think we can, but we need to collaborate to do that. That's my view.
Yeah,
I would build on that, and I would also say that an element too there is provide the funding for the companies to get to commercialization, because otherwise all of this funding has been poured in order to develop the research, the early stage, the beginning of the companies, and then there's this gap. And everyone needs to look for funding from somewhere. And so where do you look around? There's nothing coming from Canada. Okay, I guess I'll take this investment I can get in the US, in the UK, in Europe, somewhere else. And so we need to fund every stage of that journey to make sure that we can keep companies in Canada.
So my lesson to this is run fast, put money into the ecosystem so we have more foundational research being done close to the technology, so the science and the technologies are talking together, and make sure that you provide the springboard for the SMEs to really take all of the l'essor qu'ils pourraient prendre. Thank you very much to all of you. I'm really grateful for you to have been here today. And to close this session, I would like to now invite my colleague, Sharon Irwin. She's Acting Director General at the Automotive, Transportation, and Digital Technology Branch from Innovation, Science, and Economic Development, better known as ISED, to say a few words about commercialization technologies being considered by the government and what quantum adoption could mean for Canadians. So I understand that she's with us, and I'm going to ask the technical team if it's possible to put her on screen.
Oh, good. Hopefully, can you hear me? That's the other challenge
Yes,
I've had this evening with everybody else. So thank you, and apologies. I was late for the panel a little bit earlier. I'll blame some of that on central agencies. I'll blame some of that on my technical challenges. But again, I'm glad this whole thing has been recorded so I can catch up a little bit later on the few, I guess, the first 20 minutes or so that I missed. First of all, from an ISED perspective, thank you very much for inviting me to participate, to listen in on this dialogue today. And thanks to all the panelists for the time you took out of your busy schedules to discuss, not only the opportunities, but where some of the challenges are that we have in bringing sort of quantum innovations to market. Certainly been fascinating, informative, and I say that from the perspective of someone engaged in industrial policy development. Some of the things that I heard, and I've been furiously taking notes, so I'll look down occasionally so I can pull up a little bit of what my takeaways from this. The obvious, we sort of start with quantum technology will transform how we, develop and design everything, and its disruptive impact cannot be understated. While I still have a lot to learn, and I recognize that, I come away from this really firmly believing that there's enormous commercialization side, and that we have the right ingredients, we have the entrepreneurs, we have the research and development to get us there, and we're well positioned to do so. From a Government of Canada perspective, and the department I work with in Innovation, Science, and Economic Development with my colleagues in NRC and elsewhere, we've been key supporters to date, for a number of years, probably over the last decade or so, through a variety of programs and initiatives. And as most of you have pointed out, a lot of this has been through research, granting agencies, different programs more focused on that element of it. But I think my message here is that, what we look at and we took away from, I think, some of the later comments on this panel today is future success and support will also need to include how we move some of that support, funding and otherwise, into commercialization efforts and commercial investment. It was mentioned, and I know most folks here realize, have noted the government's commitment through Budget 2021 to build up on earlier investments, and over the next number of years, starting in the next year, we're going to start looking at the quantum strategy and hopefully be in a position to launch it. Our intent with that strategy, working across a number of parties within my department and elsewhere, is how do we look at amplifying Canada's strengths, as you've highlighted, in not only research, but where we have quantum-ready technologies, companies, and talent. There's various ways to achieve that, and hopefully solidify our leadership as a country in some of these areas. I know, from my perspective, I've gained valuable insights just listening to I would say, the talent that was around this panel this evening, from all different aspects of the spectrum around quantum technology development, commercialization, and otherwise. Those, again, bring back to the office and inform our work as we continue to work with our colleagues in science, research, NRC, other parties in the development of a strategy. certainly I heard about the importance of talent. I heard about the importance of collaboration, international involvement, networks, funding, communication, and engagement is key to success, whether it be in terms of how we grow the sector, but also from the strategy success that we are committed to do. And as we move from research to commercialization, as highlighted by yourself, what I heard was it's clear that end users need to play a greater role. I heard about technical folks, being integrated. I heard about, don't forget about the business side of it, and all those various elements that need to come together. That more work needs to be done in terms of how we sell quantum technologies to people. How do we get people comfortable with using quantum technology? And I think that's something that, as a policy analyst by training, struggle with. So really look forward to working with the community, yourselves and others, to ensure that what we bring together as a strategy is a success and works collectively for all the stakeholders involved in it. Developing a pipeline that can advance research, commercialization, and adoption of technologies is vital, in my view. So increasing those industry, academia, government collaborations through a number of means will be key. I was very pleased to hear that come across in the panel this afternoon. So again, I'm not going to take too much more time than that. I just want to thank everybody again. I think this has been thank the CSPC for putting on this panel, and our colleague Geneviève and team for supporting this. Looking forward to working with you and with engaging again with other folks that have probably more to offer than an hour and a half panel can do as we move along on the development of quantum strategy and really start to hit all elements of what's needed for success. Thanks very much and have a great evening.
Thank you very much, Lauren. I really appreciate you bringing together everything that we've been talking about just before. So it was done in a grandiose way. What I get also out of this is this importance of an increased dialogue. I think we should meet again, maybe in a year or two, to say if we've progressed and if we have not, what we should do right now, right there, so that we are making sure that we do have the trainees when it comes time to welcome a new SME into our world. Or if a big company wants to explore, just like the Bank of Canada did, what quantum can do for them. I did understand well the need for support and from government. Someone spoke about the NRC Challenge Program. I really appreciate it. And yes, we will continue to deliver those for sure. But I also keep in mind what Mark said. We can run fast and we need to run fast. And it brings me back to a legend. And I don't know if you know about this, but you can find it easily on the internet. It's called The Legend of the Lion and the Gazelles. And as the lion wakes up in the morning, he's thinking about the gazelle that he's going to catch, and he's got to run fast. And as the gazelle wakes up in the morning, she's thinking of the lion and how fast she's got to run. Definitely, this is exactly what this is. And I'm hoping that our gazelles, our young SMEs that are starting, are going to be so successful that the lion will never find them, but that the VCs will help them out, that their clients will tell them clearly what is needed, and that the government will be supporting them. So it's the last minute that we have in front of us. Again, I would like to thank our panelists, and I'm going to name them all. So Mark Ritter from IBM, Rachel Taylor from SB Quantum, Nick Werstyuk from the Quantum Valley Ideas Lab, Eric Center from the Bank of Canada, and I think Kimberly Hall from Dalhousie University, a great researcher. And again, thank you, Sharon from ISED, for this closure of this wonderful panel. You were great. You were even talking among each other at one point. So this is fantastic. Again, thank you very much. And I hope we will see you soon, very soon again.
Thank you so much. Bye-bye.